Hello. Firstly, I just want to say how impressed I am that how many of you chose to come to a programming talk at 5:30 p.m. on a nice sunny day. I must be awesome. That's great. So, overthrowing the Monobehavior tyranny in a glorious Scriptable Object revolution. What am I going to talk about exactly? So firstly, I'm going to talk about why Monobehavior sucks, why it is horrible, why it causes us endless pain day in, day out. I'm going to talk about what Scriptable Objects are and why they are better. I'm going to talk about how to use them, because I would be kind of a tease if I didn't. I'm going to talk about some patterns that you might use Scriptable Object to create. And lastly, I'm going to show you Pimp my tanks, which will make sense when we get there. So firstly, a little bit about me. So I'm in the sustained engineering department at Unity. So I work on the quality of Unity and its long-term feasibility as something that we can actually continue to make for a long period of time. As such, I take out hacks from the code base and I put in good things instead. And also, sometimes I write features, culling group, JSON, stuff. It's good. It's fun. And sometimes I do community stuff. Some of you may have seen me on the forums or on Twitter, things like that. I go by the name Superpig. Before Unity, I was an indie dev. I've worked at Rebellion, at Natural Motion. I was at GameDev.net for about 7 years. Yes, I'm Superpig on Twitter. And that's enough about me, because as awesome as I am, that's not what you actually came here to hear about. So, the Monobehavior tyranny. What is the situation in the Monobehavior tyranny under the iron rule of Monobehavior? Firstly, most scripts are written as monobehaviors. This is not news to any of you. They are attached to game objects. They live in the scene or in prefabs. And they receive some callbacks from Unity, update, start, etc. Now, the thing about the Monobehavior tyranny, it is a horrible, horrible place. It makes Pepe sad. They all get reset when you exit play mode. All the monobehaviors in your scene, you can be in the middle of gameplay, you've tweaked a bunch of values, whatever, you exit play mode, and it is all gone. So that sucks. They're fully copied when you instantiate. If you have a complex character, and you want to instantiate, you end up making a full copy of all the monobehaviors on him and all the data in all those monobehaviors. It's awkward to share them between scenes. It's awkward to share them between projects. Not the scripts themselves, but the actual instances, the actual behavior instances with data in them. It's awkward to share them around. They've got bad version control granularity. You want to go and make a change to one monobehavior, you're checking in a whole scene file. Odds of merge conflicts very high in any project where other people are also working on the same scene file. You can customize them inconsistently. So usually this happens by accident, but suppose you have 5 orcs, and you misclick, and suddenly one of them has 300 health instead of 100 health. Finding that is difficult. It relies on QA happening to notice that one of these orcs takes a really long time to kill. And sometimes you want to do this, but more often than not, from a game design point of view, you don't want one of these orcs that looks identical to all the rest to, for some inexplicable reason, take 3 times as much to kill. And lastly, the thing that appeals to me the most, they're just kind of a bad conceptual fit for a lot of the things that we want to do. A lot of the things that we want to build, they're not kind of components of an object. They're not things that belong somewhere in space and time. They're just pure data. So, how can we be saved from the monobehavior tyranny? Can pure C# statics save us, perhaps? They still get reset when you exit play mode. We have to do our own serialization of them. It's not very easy to reference Unity objects from a C# static. We have to write our own inspector code. So if you're OK doing that, that's fine. But we're using an engine to avoid writing all our own stuff. We don't want to have to build all of this mechanisms around statics in order to be able to share the data around between scenes and all the rest of this stuff. What about prefabs? Prefabs are a reasonable solution to a lot of this, actually. you can put your component on a prefab, you set up all the data there, and then you can reference that from all the different scenes you want to use it in. You can copy the prefab out easily to put it into a different project. It's got OK VCS granularity. It's still easy to screw up, sort of instantiate them by accident. You make some manager prefab that has a lot of data on, you drag and drop it into the scene by mistake, or more likely someone else on your project does, and then you have to shout at them. It has extra components as well, and that's often not ideal either. You've got this kind of data thing, and then someone adds an audio source to your data thing. Like, what does that even mean? I've got a table of enemy values, or like a drop list or something, and it has audio as well. And that doesn't make any sense. So there's still not really an ideal conceptual fit. So sort of solution-wise, it's like, well, yeah, no, never mind. So, Scriptable Object to the rescue. It's Monobehavior, Jim, but not a component. Which is actually quite literally true from the engine's point of view. We actually use the same class inside of Unity for Monobehavior as we do for Scriptable Object. It just happens to be the special setup whereby it's not a component. You just derive from Scriptable Object instead of Monobehavior. It cannot be attached to any game objects. It can be serialized, and it can be inspected, just like Monobehavior. So if you've selected a Scriptable Object, you see it in the inspector, you can change the values and so on, exactly the same workflows you're used to with components. It can be put into .asset files. And this is where things start to get very interesting. You can effectively make custom asset types in your project. So you've got your textures, you've got your materials, you've got your scenes, you've got your FBXs, and you've got like a bunch of information about inventory items, something like that, just as different files in that. It also solves some polymorphism problems. If you've come up deep into Unity serialization code before, you will have discovered that you can't kind of use subclasses of things and then have them serialized correctly. With Scriptable Object, you can actually work around a lot of that. So how exactly does it solve these problems then, just to make it super, super clear? So the first thing is that because we're saving these things in assets, they're not reset on exiting play mode. Just like changing a material or texture input settings or anything like that, we don't reset things in the project when you exit play mode, only things in the scene. So by keeping it out of the scene, we avoid the reset problem. They can be referenced instead of copied on instantiate. So all of the data that was packed into your enemy, all the different stat values for different things that you do at different times, whatever, instead of every single instance of your enemy having its own copy of all those values, they all just point to one asset that has the data in it once. So your memory usage comes down, speed of instantiate goes up. Much like other assets, it can be referenced from any scene. So sharing them between scenes is kind of a non-issue. It's like asking, can I share a texture between scenes? Sure, you just reference it. It's easier to transfer them between projects. You still need the actual class definitions for the class that you're using for Scriptable Object. But once you've done that, you can just kind of copy the asset file through one place to another. There's no kind of having to dig in hierarchies to find the right place to get it from. There's no need to kind of try and extract things from scenes or anything like that. You get perfect VCS granularity, kind of whatever you like. One file equals one object, and most VCSs are operating on a kind of a file basis. So you want to go and change one enemy's information, that's one Scriptable Object, that's one .asset file, that's one checkout from Perforce or check into Git or whatever you like. But you can also combine them together as well if you want, and you have total control over it, rather than with scenes and prefabs and so on, where it's not maybe quite so ideal. And there's just no extra unnecessary parts. Scriptable objects don't have a mandatory transform component or anything like that. They just have what you put there, and that's it, nothing else. It's not perfect. It does cause us pain in a few ways. They get very, very few callbacks. So unlike Monobehavior, which is kind of an active participant in the player loop community, they don't get updates, they don't get starts or anything like that. They get on enable, they get on disable, and they get on destroy. And that is it. And I'll talk more a little bit later about exactly when those happen. You can work around this with proxy monobehavior. So you put a monobehavior into the scene that doesn't do very much except call the things it needs to call on the Scriptable object. And we'll look at some examples of how you might use that. The second major thing that tends to trip people up is that shared data really does mean shared data. If you're used to having prefabs and just like components on things where you can go in and customize values and so on, and you're kind of used to this idea that, okay, I'm just going to affect this one object here and not break my entire game. When you switch over to using Scriptable Objects, you can find yourself making a few mistakes when you get started, and you change one thing, and then like, no, really, that is everything in the game you're changing, because it all uses that same shared asset. So it can take a little bit of getting used to from a workflow point of view. But as I said before, there is this problem of overriding things by an instance where you don't mean to. So it is a blessing. It is also a curse. So it's kind of decide exactly where you want to do it, and just get used to it from the workflow, train your people. So how do we use Scriptable Object? If you saw the version of this talk that I did a couple of years ago, then there was several slides here about writing editor code, which is all gone, which is very nice. Because what we have is a simple Scriptable Object. So it's a very, very simple class. I just have one variable in there just to demonstrate. And all I've done is I've derived from Scriptable Object instead of Monobehavior. And there's two ways that I can create these things. One of them is to stick this attribute on it. And that will make this class show up in the menus, in the assets create submenu, just like scripts on Monobehavior, and, automatically appearing in component scripts. Yeah? If you don't put it there, it won't show up by default, but you can add it in and you can customize kind of how it's going to show up. And so when you go and choose it from the menu, it will automatically create a new .asset file with a Scriptable Object inside it that you can begin to edit. The other thing you can do is you can create it directly from code using create instance. And so you call create instance with the type, and this makes a Scriptable Object that just lives in memory. It's not associated with any assets or anything like that. You can then associate it with an asset if you want, but you can equally just create something in memory, use it for some things, and then destroy it when it's done, or even just let the garbage collector pick it up for you. So, to talk a little bit more about the callbacks. Firstly, on enable, it happens when the object is created. It happens when it's loaded. And that's kind of a tricky one, because it's not always obvious when something will be loaded. But if you open a scene that has a reference to the Scriptable Object, at that point, the Scriptable Object will be loaded, for example. And when you finish reloading all the script assemblies, so if you've changed some code and you recompile, at the end of the recompile, when it kind of reloads all of the compiled results, you'll get on enable in all of your Scriptable Objects. Then on disable, you get that when you're about to reload all the script assemblies. So at the when the compile is finished, we disable all the Scriptable Objects, reload the assemblies, and then on enable them all. And when you're about to destroy a Scriptable Object as well, you get a disable first. And then lastly, on destroy. After the on disable, you get the actual on destroy call. Okay? So they're pretty simple. But on enable and on disable between them give you quite a lot of opportunities for going and subscribing to things, going and subscribing to update hooks or things like that, going and looking for things in the scene that you want to tell it, call me back when something happens. But we'll look at examples of that later. So the lifetime of these things is something else that people often find is quite unclear. And they're just the same as any other asset. It's different to Monobehavior. It's not based on like when you destroy the scene or when you delete the object or things like that. It's the same as any other asset, which means that when it's persistent, which means bound to a .asset file or in an asset bundle or anything like that, then it can actually be kind of cleared out of memory at any time by the asset GC. So if you call resources.unload unused assets, there's a Scriptable Object bound to a .asset file that nothing is using right now, it just gets wiped out from memory. We call on disable first and on destroy. If there's any scripts that have references, then those keep it alive. But it's fine that we do this, because as soon as you actually need it, we can just reload it again. And this is why we only do it when it has some kind of .asset file or asset bundle or something like that backing it up, is so that we know we can get it again when you actually want it. If it's not persistent, if it's just being created from code with a create instance, so there's no .asset file behind it, then it can be destroyed by the asset garbage collector. So if you've created this thing in memory, you did some stuff, and then all your references to it went away, so you don't have any scripts, any variables at all holding references to it, then when resources unload unused assets runs, it may wipe it out. You can stop that from happening using hide flags. If you set hide and don't save on it, we skip all of those in the asset garbage collector. So that's a way of having this object, sits in memory, doesn't really do anything, but won't get garbage collected, and you can always retrieve it again using something like find objects of type. So let's look at a couple of patterns. What might you build with this scriptable object thing? Most people think that it's just a kind of a pure data container, but you can do a little bit more with it than that. Still, we'll look at the data container case first. So building like data objects and tables out of things. So taking like a plain old data class, binding it to an asset file so you can just click it in the project window and start changing the values in the inspector. And then, of course, commit the whole thing to version control as a single file. So you want to go in as a game designer and tweak something. You can just get that one file in the project and tweak it without touching the scene file at all, without touching prefabs or whatever that the artists are working on or anything like that. Custom editors make it even nicer. I definitely recommend sticking custom editors on top of this stuff so you can get a really good kind of sort of full asset experience. You've got to make some decisions, like, for example, do you want to have kind of one scriptable object per kind of entry in your set of data, or do you going to have like one for the entire sort of table of data? If you're making, for example, a string table for localization, you probably don't want to have an individual asset for each and every string. But if you're making something like enemy templates, then maybe you want to have a separate asset for each enemy template. It's going to depend very much on your project, exactly what the right kind of call is. So some examples of this, so there's localization, inventory items, drop tables, enemy config and templates, pretty much any kind of thing where none of these things need to be in a physical location in a scene. None of them really do anything. They're just data, and they can just sit there, and they can just be assets in the project, and stay out of the way of everybody who's actually working on the scene, and just sort of avoid that whole high contention area. So to look at a really quick code example for what that looks like. So I suppose I have my enemy info, which is a scriptable object that's storing the maximum health and the damage per melee hit. Now remember, this is shared. So I can't store any per enemy variables here as well. I can't have the enemy's current health, because that value will differ from enemy instance to enemy instance. But the maximum value is shared between all of them. So I set up that, and then, for example, I have my enemy component that I am still attaching to things in the scene that just has a reference to that. So I've been able to take two variables out from the scene and replace them with just one. And obviously, in a real game, you'd have more than just two variables. You can get all of them out and just have that one reference in the scene. So it's a pretty simple case. It's one of the most common ways to use scriptable objects. That's fine. It works very well. But let's look at a few other patterns. So firstly, something I like to call extendable enums. And this is just the idea of having an empty scriptable object that's bound to a .asset file. Now, you might think that an empty scriptable object is going to be pretty useless. But there's a couple of important things you can do with an empty scriptable object. You can check if it's equal to another empty scriptable object, or you can check if it's not equal, or you can check if it's null. And it turns out that that's the same set of things you want to do with an enum. So it's like having an enum where you're going to sort of check, is it this value, is it this value, is it this value? Except that instead of it being hard-coded, it's something that can actually be created by designers directly inside the project. So examples for these, again, might include inventory items, or AI event categories, or damage types, or sort of lock and key setups. So to pick the inventory item example, maybe I have a bunch of scriptable objects that don't really represent, well, that represent objects but don't have any actual data associated with them. But it gives me the ability in code to say, if the player's inventory contains this scriptable object, then let them through, otherwise don't. I think. So to look at an example for that. Oh, yes, and one other point. It's also very easy, given the empty scriptable object, to then begin adding variables to it if you discover you need them, at which point it's very similar to the data table setup. And it supports null, as I said. So let's look at a little example. So this is from a game I worked on a little while ago. Given something like different types of ammunition, I might have a very simple ammo type scriptable object, Doesn't really do anything in particular, but I just want to kind of keep track of, I got this much 9mm and this much RPG rounds or something like that. From the game's point of view, it doesn't really need to know anything about these. It's just different numbers to keep track of. But it allows me to start with my basic class and then write code like this. So given an inventory, which is like a dictionary of this ammo type to numbers, or something like that, I can just plug in the ammo type instance and look it up by that. So it ends up looking very, very similar to using an enum, except that suddenly I've given my designers the ability to create 50,000 different types of ammunition in the game if they so desire. It's maybe less relevant for an individual game, but certainly for like an asset store author creating some kind of asset that's going to be used in lots of games, it's quite handy. And then, yeah, so just kind of using it like that. So, pattern 3, dual serialization. So as I said, one of the nice advantages to using Scriptable is that it is fully compatible with Unity's serialization system. So you create one of these things, you can throw it in the project, look at it in the inspector, include it in builds and so on, and Unity will just make all that work. But you could also add your own serialization as well. Scriptable objects are fully compatible with the JSON utility overwrite method, which means that what you can have is like a mixture of assets that you've created during design time that are being serialized with Unity's serializer, and assets that got created after that that are being stored as JSON. So an example of this is having both built-in and user-authored levels. You might create some of your levels as Scriptable Object instances at design time, just save them in the project, hold them in there. But then you ship a level editor, you let people edit the levels at runtime, and you save those out as JSON. And it lets you build an architecture whereby you don't have to care whether or not this object came from inside the project or from JSON. You just load it in however, and you end up with a Scriptable object in memory that has the data that you need to set up your level. So an example for this, given a level data Scriptable object that contains whatever values, and I create asset menu attribute on it so that my designers can just go to the menu, new level, and then start setting values into it. I can then have something like load level from file, which given the path to some file, reads in the full text, makes a level data object, and deserializes the text as JSON into the object, overwriting all the fields, and then returning it. So I just hand over a file path, I get back an entire Unity Engine object. So we'll look at one more pattern. So reload proof singletons. This is something that came up on the Unity beta list quite recently. How many of you have ever tried to make a game that actually respects Unity's ability to edit the code and recompile in the middle of play mode? My guess is that many of you have tried, but very few of you still have a game that does that, because most people give up pretty quickly, because it's quite difficult. But here is one technique that may help kind of prolong that a little longer until we fix all the remaining problems that stop people from being able to do that. So the pattern's pretty simple. You have a Scriptable object plus a static instance variable. So you make one of these Scriptable object instances, and you store the reference to it in the static variable. And then after a domain reload, because these things can survive that, if you've set the hide flags on it correctly, you can kind of repopulate that static instance variable using findObjectWithType to go and relocate the thing after the reference got lost. So an example of this one is global game state. If you've ever just had static variables for things, storing players' health or score or things like that, those will get wiped out on domain reload, and also it's kind of a pain. You can't inspect them easily. If you put them inside a Scriptable object type and set this up, then they survive domain reload, and you can look at them in the inspector very easily and kind of see the state of things. So a little example of this. What does it look like? So we start declaring a class, game state, it's a Scriptable object. We have a couple of variables in there. They're going to be serialized. And we have a static game state instance variable that's private. We use a public instance property to kind of wrap around that. And we just say in the property, if we don't have that reference right now, firstly, we'll try and find it. We'll try and find it from the thing that was left from before the domain reload. If we still don't have it, go create it. At which point we definitely have it. So return it. And we're done. So this is a very nice little pattern. And you can wrap this sort of thing up into a base class as well that you then just derive from. It can be a little awkward with the static variables sometimes, but there's ways of kind of helping set it up. Oh yes, one more pattern as well. Delegate objects. If you've ever done any native OS X or iOS work, this is probably going to be quite a familiar pattern. But it's this idea of having a scriptable object that has methods, because they don't just have to contain data. There's arbitrary class. They can have whatever methods they like. And the Monobehavior passes itself to the scriptable object methods, and the scriptable object does some work, possibly using the Monobehavior if it needs to, ignoring it if it doesn't. And this allows for an awful lot of kind of pluggable, configurable behavior. And we'll look at an example of this shortly. But some examples include like different sort of pluggable AI types, or maybe like power-up buffs and debuffs. So instead of having to make like a completely separate prefab for every individual sort of pickup that the player could get, you could have one sort of generic one that has a scriptable object that's actually going to do the work of buffing the player and so on. So a little example of what that can look like. So given like a power-up effect scriptable object, which is an abstract class, so we're going to use this as a base class for the individual actual effects of different power-ups. And all it has is this one method that lets you apply this power-up effect to one particular object, one particular player or something like that. And then we have an example of one of the power-up effects. So like a health booster effect. We can configure the amount of health it's going to give. And then when we're applying it to a particular object, we're getting the health from it, and we're adding the amount to it. And by doing it this way, this actually lets us create then like 10 different health power-ups of different strengths. So we can make like a mini health power-up and a macro health power-up with different amount values using the same class. And then when it comes to the actual power-up object that the player's going to pick up, we're sort of saying, OK, so when the player enters the trigger, we apply the effect to them, like that. So the power-up Monobehavior has delegated all of its actual work it's going to do to the scriptable object, and its delegate pattern. So let's look at some of this stuff in practice with Tank's demo. So just to explain what that is a little bit first. So this was the training day demo from Unite Boston 2015. And it was pretty cool, but I thought I'd look at it and say, OK, well, how can I use Scriptable Object to kind of like pimp this up another level? So I decided to beef up the audio a little bit. I decided to add destructible buildings, complete with camera shake for really big buildings falling down. I added like pluggable AIs as well. And I made configurable game settings with load and save of like the settings that you set up. So I'm going to walk through how I did all of those things. Yes. So what we have right now is the original Tanks project as was. So probably everybody's seen this before. It's a simple two-player game. So I can just drive around. If I had, a friend, then they could drive the second tank. But I have no friends, so I'm just going to blow it up because I'm sad about having no friends. Blowing things up makes me feel better. There we go. Excellent. So it's pretty simple, but I can't, I can't do anything to the buildings or anything like that. It's quite boring, playing against another player who just sits there and doesn't do anything. It's not very fun. And as well, the audio is maybe a little quiet, but could we turn the audio up a sec? Up. Yeah. So that explosion is kind of A, dull, and B, repetitive. So let's start with the audio as a simple thing. So one of the first tricks for beefing up audio is just to add a couple more clips and then randomize which clip you use and to randomize the pitch and the volume slightly. So you could do this on Monobehavior, where you just go in and for all the places where you have these different sounds that you want to kind of tweak a little bit, you go in and you write in minimum pitch to use, maximum pitch to use, and you keep writing randomization code over and over and over. But it's much cleaner to try and encapsulate all of that in one place. So what we do have is this audio event idea. And this is an example of the delegate pattern. So given some audio source, we can play the audio event with that audio source. And then the simple implementation is to have this one sort of simple audio event. So I give it some clips, I can set a volume, I can set a pitch, and then it picks one of the clips at random, it randomizes the volume, it randomizes the pitch, and it plays the source. And this has create asset and manual on it, so I can go to here, and I can make a new simple audio event. So I'll lock the inspector a second. Here. So I've got a couple of explosion clips acquired from archive.org. I'll throw these in here. Let's say volume. Okay, well, 0 is going to be a bit quiet. So we'll try that kind of range. And then we'll play it between quarter speed up. Oh, no. Quarter down. Like that. So. There's one sample in there that's definitely quite a lot louder than the others. So if I take a look at them in the inspector for a second, we'll probably see. Oh yeah, it's that one. That's going to be the one. So I'll just take that one out. So. A bit more interesting, right? And you can imagine an audio designer being able to kind of go into the project, grab an asset like this, and just tweak the volumes and pitches. So let's move forward a little bit in time. So in classic Blue Peter fashion, here's one I made earlier. And I think at this point I had it set up in the scene as well. So, oh no, wait, that's right, that's on the tank. So on the tank, yes. No. What? Did I set this up? I've forgotten how far I got. That's odd. Okay. Well. There we go. Yeah, I did. Okay. So already it's quite a bit more interesting to actually just fire and blow things up. It's still a little loud, I'd say. So I'll just grab that event and say, okay, let's just bring the volume down further. Also, I think it's not really bassy enough. Let's bring the pitch down a bit. It's a little better, I guess. And I can exit play mode, and all the changes are kept. So I'm able to kind of live mix everything until the audio events are how I like them. Exit play mode, the changes are just kept, and I just commit the changes, and it's fine. So that was pushing forward the audio stuff. There's a few more events that get set up later on, but let's move forward to destruction. So there's a few buildings in the scene, but having them all blow up the same way would again be a little bit repetitive and boring. We've got these relatively small little things here and there, and then these sort of bunkers, and then there's this big radar dish tower thing, this massive refinery over here. Ideally, we give them a little bit of variety, some different effects, a little bit of setup. So what have we got for this? So firstly, a component to go onto the destructible objects themselves, because we don't want everything to be destructible. We need something to signal it. So this deals with like the health for the buildings, as well as dealing with the tanks driving into them, because I figured you can't really drive a tank into a building without it taking some damage. And then once the health drops below 0, if a destruction sequence has been plugged in, then start running the destruction sequence as a coroutine. The destruction sequence looks like this. Again, it's an abstract class. And this time, the method that's on there, it takes the Monobehavior that's going to kind of run the destruction as an input, and it returns IEnumerator, because the Monobehavior, the scriptable object in this case, is going to contain a coroutine. Scriptable objects themselves can't run coroutines, but Monobehavior can run coroutines kind of given to it by other objects. It's something people don't often define, but just because you're running a coroutine on this Monobehavior doesn't mean the code has to be inside the same class. So we put the code for the coroutine inside one class, and we run it on the other one. So if I, again, step it forward. Okay, so I've added a couple of sequences here. So there's a very simple one, hide behind effect, which instantiates a particle effect at the object that I'm blowing up, waits for a certain amount of time, and then destroys the original thing. So the idea is that you'd use this to like throw up a massive explosion, and then sometime in the middle of the effect, you just like delete the game object in the middle of it, and it would be hidden by the particle effect that's going on. So it's a pretty simple one, and I can kind of set which effect it's going to use and set how long it should be before it tries to clean up the original object. For a slightly more elaborate sequence, controlled demolition. So this one sets up dust particles rising from the ground, playing a collapse audio event as well, building the same audio events from before, turning off the collider straight away, starting camera shake going, and then gradually either scaling or sliding the building into the ground. So that should be pretty fun. So if I look at some of the buildings that I've got in here, they've got the destructible script applied, and I've been able to apply specific sequences to them. So I've got like a big building scriptable object destruction effect in this case, which is a controlled demolition. It's going to take 2 seconds. It's going to wobble the building around by 0.3. It's going to use this particle system and play this sound effect and so on. As opposed to the small building, which collapses much faster and just rather than a full celebration, just says yeah, and things like that. And then custom ones for the radar tower and the refinery. So let's take a look at how that looks now. There we go. The radar tower's a good one. I may have messed with the physics slightly. There we go. Gradual collapse into the ground. And meanwhile, if I try one of the smaller buildings, that one just has a big cloud, and then it turns off in the middle of it, so it's using the hide behind effect instead. I think this one as well. Nope. Oh, I'm blowing myself up. Never mind. Okay, we'll move on to the next part. So, having done destructible stuff, I was like, okay, well, now it's about time I have someone to play with, and that will have to be a computer. So, pluggable AIs. Nope. Brains. Yeah. So, as Tanks was originally written, there were a couple of components for doing moving and shooting that did all the reading from the player's inputs and then applied them directly to changing the velocity of the game object and charging the cannon effects and then spawning the projectiles and so on. And so the first thing I did was just to separate that out. So we have, again, this delegate pattern with a tank brain that can be initialized and then has this think step. So the idea is that every frame, each tank will think, and kind of the brain will then set up whatever it needs to set up on the tank. So we have a player-controlled tank as our first brain. So this is just allowing us to continue playing it as an interactive game. So For think, we just get the components. We do the steering for movement based on the player's input. And then, based on whether they're pressing the fire button or not, we either begin charging a shot or we finish charging a shot and fire it. So this allows us already, because we have 2 brains in here, one for human 1, and then we've just configured it to player 1, one for human 2, configured to player 2. And that just configures which set of inputs it's going to try and read from. So we could create another 6 of these things to have 8 players ready and set up. So nothing should really be different at this point. It should still pretty much, yeah. So yeah, there we go. So all I've done at this point is just separate the actual decision-making about what the input should be from the execution of the result. And of course, there is the one missing component to that as well, which is not in here. It's in the tank folder. It's tank thinker. And this is the thing that actually calls think on the brain. So this is the thing that's doing the delegating. So when you look at what's here, you can see at the top we've got this public tank brain. So that's where we're plugging in the brain. And then I decided to add as well a little bit of stuff for just storing and recalling key values. So I have this remember, where I can give it a string and some value, and then another version of it where I just give it the string and I get back the value. So it's a little kind of blackboard. I can just store arbitrary data in there, arbitrary kind of instance-specific stuff that the brain wants to kind of remember about, which enemy it's going after right now, or what it decided to do last frame, so it does the same thing next frame and stuff like that. And so you see, in update, we just do brain.think this, and that's all it really does. So to move forward a little bit more. OK, so I've added a couple of very simple AIs. So we have this random walking tank, which will sit idle for a little while, and then move randomly for a little while, and then fire a random distance, and then repeat. And then we have as well the simple sniper brain, which will pick a target, pivot towards it, and then fire, and then wait a little bit, and then fire again, and we'll keep firing until it's killed that target, and then we'll try something else. So it's not very interesting. It doesn't drive around, but it will just keep shooting and just spawn camping or whatever. And so to go with this, then, I've created actual instances of these. So the random walking tank, I created an idiot brain. And I created a sniper. And I could make the sniper more difficult by decreasing the time between shots or something like that. And if we look at the setup for tanks. So here is where I'm kind of initializing my 2 tanks. So I'm using human 1 and human 2. So let's say instead I want to use the idiot brain for the opponent. And finally, I have something moving to shoot at. And it's just going to... Yeah! No. Stay still. Ah. There we go. Right. It shouldn't take me that long to kill an idiot, but never mind. So pluggable AIs. So you can imagine writing any number of other sort of strategies in there, creating instances from them, configuring them in different ways, and then just plugging it in, and off it goes. I mean, I could set up idiot versus sniper as a match, but we'd be here for 20 minutes just waiting for them to eventually blow themselves up, so we'll skip that. So let's move on to the last little bit. So I decided at this point that it's nice having this one level, but every game needs menu screen and game over screen and all the rest of these things, where we can begin to actually configure what kind of enemies we want to play against, and how many different players there should be, and stuff like that. So I'll set up a couple more scenes. So start with the main menu scene. I apologize for the terrible programmer art. And yeah, so why is there no typing? Oh, it's going to be the font is wrong, or something like that. Okay, names don't matter. So I'll have human 1 and human 2 versus a team of snipers. and let's just play one round. Right. So I'm the blue one. Oh, bloody hell. Try and kill one of them at least, please. Oh, for heaven's sake. It's shocking. It's shocking behavior. Okay, you know what? I'm going to try this again with idiot AIs instead. I'll go faster. And you know what? We'll just turn those off, actually. I just want to demonstrate. Did you notice, by the way, how I opened up the scene and it had the same settings from the last time I played there? Just throwing that out there. So I'll go and kill red. There we go. And take out green quickly. There we go. So a simple game over screen as well. So it's kept track of how many wins I had. No, yes, that's the names. Okay. So, back to the menu. So how do I deal with the saving the player names and colors and brain settings, and how do I deal with the game state as well? So let's start it up again quickly. I've got a couple of scriptable objects set behind it all, and I can show them here. So game settings, I can see Richard, Dr. Charles Lerps, player 456, set to the appropriate brain types, and number of rounds. And then I've also got my game state, so I can see 3 players are in place. They have no active tank instance right now, and they've got no wins, and we're round number 0. If I jump in, object. State. There we go. Right, so round number 1, and you can see it's got 9 up all the instances, so I'm able to kind of retrieve. If I can get hold of this object, I can then find out anything I need to know about who's got how many points and so on. So what does that look like in code? So this is where it starts getting a little bit complex, and I'm going to go quite fast because I'm going to put this all up online somewhere so you can just take a look at the code later, but it's quite boring watching someone just talk through code on a stage. So we've got pretty simple stuff. So we have the game state itself, which is using this reloadable singleton pattern that I mentioned. So it has this static game state field, public property for accessing it as well, and then so if it doesn't have it, find it. If it still doesn't have it, create it. Otherwise, return it. So then for each player, we have like the active tank, total wins, whether it's alive. Yeah, pretty simple stuff. And then a couple of useful things like, find me the player who has the most wins right now, just so I can kind of say who's the final winner at the end of the game. And then similarly, we have game settings. And this one also is using the reloadable singleton pattern, as you can see with the instance variables there. But it's also using the dual serialization pattern. So you have this load from JSON and save to JSON methods, where it will just go through and just blat it all to text, send it out to a file on disk. Yeah. Oh, yes. And I also, at the same time, I moved some of the actual gameplay logic in here as well. So this is one of the nice ways that you could create, for example, different game modes. If you want, like, whoever kills the first tank wins. If you wanted, like, team play or something like that, you could just have all of these as different Scriptable Object subclasses, and you just plug in one of these as a kind of a delegate to make the decisions about, who scores the point when a tank is destroyed. I could make a game mode that's about blowing up all the buildings before anyone else takes any damage or something like that, very easily on top of this kind of setup. Yeah. And then the rest of the code is really just dealing with the user interface. But you can see that when I am starting the main menu up, I have this thing for like my path where I'm going to save my settings. I'm using application persistent data path. I'm just like inside that folder a tank settings.json file. And so I'm saying when the game starts, if that file exists, then load the saved settings from there. Otherwise, just initialize them from default settings. Yeah, and then just wire stuff up. And then when I begin to play, actually save the settings to the same path, and then begin to create the state based on the settings. I'll put all this code up online, so don't worry too much if you can't like read it very easily. Yeah. One of the other useful things that did get done was if you are in the middle of testing, it's kind of a pain to have to keep going back to the main menu just to like initialize the settings and initialize the state and things like that. So there is also this test game settings, which is giving me 2 players, white and black. That's not doing anything. And so I can just hit play directly from here, and it's going to use those settings for me automatically. I just have a little bit of code that's sort of saying in the editor, if there are no settings because we didn't come by the main menu, then make it from the test settings. And so this gives me a very quick way to just like jump directly to any scene. You know, suppose I have 15 different landscapes or something. I can just pull up any one of them, tweak the settings directly in the inspector, and just like launch into the game at that point, and just kind of see what it's set up like. So, and that's pretty much everything I did to tanks. So, just to finish up then. Yeah. So, concluding. Scriptable Object is a vital tool in your Unity toolbox. It is by no means like actually the complete replacement to Monobehavior, but it can be used very nicely in concert with it to create a kinder, gentler Monobehavior tyranny. So yeah, it's not suited to everything, but it does actually have a lot of flexibility. It's a lot more flexible than people think when they just kind of assume it's, oh, you just put some data in it. It's like, well, yeah, you can, but there's also a lot you can do beyond that. And in particular, you can build some really awesome workflows for your project. You know, you can use these to create really designer-friendly tools. You know, lots of like editing things live in play mode, and then just like the values are just there, and it's fine, and it works, and it's great. So yeah, and I am Superpig, and questions time.